everyone, and welcome back to my channel. Just shy of a year ago I released this little compressor here. Now this little compressor maxes out at about 3 pounds and is appropriately used to replace an aquarium compressor or something for hydroponics. If you haven't seen this video, click the little tab up above there. Since that time I've been looking for something with a little bit more pressure as well as being just as simple to produce, and I come up with this. Now this is kind of still in beta format, but I present to you Compressor 2.0. First off, with the design, it's a lot heavier than the previous version. I went with a double-ended crank instead of a single-ended crank, as well as a larger diameter piston and a 3-piece cylinder made out of ABS tube and 3D printed parts. One other difference is this compressor is directional, and the reason is the cylinder offset. Now I probably could have offset the cylinder a fair amount more, however this should increase efficiency either way. This offset bore technique is used in engines, more modern engines, to increase efficiency as well as decreasing wear. Here we have a visual representation starting with the non-offsetted side and following with the offsetted side. Because of the small offset, it's not really visually noticeable. However, on the compression stroke, the connecting rod is slightly straighter, which decreases sidewall load, increasing efficiency. Also in this initial setup, I'm using a nylon piston ring. Now I'm having issue with the shrinkage of the nylon and getting the end gap right, so I'll have to spend more time fine-tuning that. For the cylinder, I printed the mount plate and the top of it from ABS. This was so I could use plumbing solvent glue to glue the head, top, and the cylinder mount on, having a little bit of the cylinder protrude so it can center into a counterbore in the crankcase. This helps to ensure a good seal as well as keep the cylinder located properly. Before I get into showing off the new compressor, I wanted to do a quick pressure test on the old compressor at what I would consider the maximum continuous running RPM. For this test, I'm using a single jug mounted to the V-twin frame, using a 540 motor that's normally supposed to run at about 12 volts and gives me about 8,000 RPM at 12 volts. I am currently powering this with about 20 volts. Since originally posting this, I've had a few questions on maximum pressure and high RPM. Since I never actually pushed this to the limit and tested it while doing so, I figure I'd throw it in here. I also released some ball bearing holding parts for this, including a connecting rod, and I plan on dropping a O-ring style piston once I get all the fitment sorted out perfectly. Now the needle's all over the place because of pressure spikes. I don't have a large enough buffer. However, I'm going to call it at about 3 pounds, which is what I've experienced in practice. As for flow volume, this motor spins twice as fast as the 5-volt version, so it should have doubled the flow. And finally, onto the new compressor. First off, I'm set up outside to do the initial baseline pressure test. I have a 2-liter pop bottle as my air tank, and whatever I end up with here is where I'm going to try and improve from, unless I magically hit the 20-pound mark that I'm kind of shooting for, which I doubt. And you can see here that it doesn't take too long to fill up the 2-liter tank and build up to about 4.5 pounds, which is good. Right off the bat, we see some definite improvements from the original design. However, I'm sure I can get a little bit more to this. Also, during testing, I did knock the belt off when bringing it to full pressure once. I might have to change the pulleys or tension the belt a little bit more. As a power source, I'm using this MY6812 motor. These are pretty standard on kids' electric scooters, other sorts of little toys, and all sorts of different things. I have collected a few of them just from scrap alone. They can be easily sourced online for about 50 bucks, give or take. This isn't the only motor that'll work, it's just the one I have. For actual power, I'm just using a 24 volt 10 amp hour battery, and I'll keep this topped up between tests. At any rate, seeing as everything seems to work alright, it's time to make improvements. The first improvement I'd like to do is remove the piston ring. Now when it comes to seals, piston rings are much better at shock load than some sort of O-ring. However, I'm not going to be into the pressures that really matter, so I designed a piston to house an O-ring, and I'm going to install it and see what happens. Switching out pistons is no big deal on this. The design is similar to a two-stroke engine, so I can just pop the cylinder off, pull out the wrist pin, and swap the new piston on. Put it back together and we should be good to go. While I have the cylinder off, you can get a nice peek into the crankcase. The footage disappeared for me swapping the piston and wrist pin. However, it should be a tap fit, but I'm going to throw a little bit of super glue in here just so it doesn't wander off. Also, with the change from piston ring to O-ring, it's harder to get an O-ring into a square bore, so I'm going to use this deburring tool to give myself a nice taper on the bottom of the bore just to make it easier to get the O-ring in. I'm also going to be liberal with the grease on this. The O-ring is going to increase the friction, so I want to have as much lubrication in there as I can get. However, I don't really want it above the O-ring, so I'm going to try not to get too much in above that. Otherwise, it'll end up into the top of the cylinder and possibly into the valves. And the cylinder slides on nicely. And I noticed here that my mounting flange has detached from the cylinder. I wasn't very liberal with the glue when I put this on, so next time around I'm going to make sure I get a lot more glue in there. This piece could also be printed as one piece, but I like the tubing for the cylinder wall. It's a little bit smoother and saves a little bit of time messing around with fitment. I added a little bit more glue and I'm going to screw it back together and we should be good to test with the O-ring piston. Back outside we go. It's a couple days later and the weather's not as nice, but we'll have to deal with it. Unfortunately, this cold, wet weather is wreaking havoc on my hose fittings. Otherwise, it seems to run alright with the O-ring piston. No seizing, no stiffening or anything. It seems to be okay, which is good. After eliminating the extra buffer to eliminate issues, we're off to the first test. Now, this isn't really what I was hoping to see, but there's room for improvement here. But before I can solve that problem, we have more line issues. And then I break the barb off. So I guess I'll take this opportunity to try and fit a tighter belt on here. I have one that seems like it might be a little bit too tight and one that seems to be alright. Now if I have to, I can always drill the mount holes in a different place on this metal plate. Well, it seems to hold air pressure, but I can literally hear the belt slipping and see the dust coming off of it. But either way, I need to fix this fitting problem before I can do any testing. Now for the fittings on this, I'm using an NPT standard 1/8 fitting. And a lot of guys will tell you to use Teflon tape, but I hate that shit. I refuse to use it unless I absolutely have to. I prefer this paste here, this pipe dope we used to call it. This stuff works better, mostly dissolves in oil so it doesn't plug up hydraulic systems. It's just better overall. It usually seals to a low pressure and you can usually return the fitting backwards slightly without having any leak issues at low pressure, which is usually under 100 pounds. I also think I failed to note I changed down to a smaller pulley on the motor to try and get a little bit more torque. As I suspected, I still have too much belt slip. So I'm going to go with the belt that I thought was too small and I'm going to stretch it on here. Also, I call them belts, but really they're just large O-rings. Ultimately, this isn't really the best way to drive anything, it's just kind of an easy thing to source relatively inexpensively. So with the tighter belt, the smaller pulley, hopefully I increased the torque and eliminated some of the slip. And that's beautiful. I got a good 6 pounds, maybe more, depending on how inaccurate this gauge is. That's not quite the 20 I was shooting for, but it'll do. This gives me a lot of information as to how to get there, and I think with this compressor I should be able to do it. However, that's going to require valves that have a little bit more spring back and aren't just atmospheric reaction valves, as well as increasing the power, which might just need a new motor because I've been beaten on this one and you can kind of hear it whining in there. But for any rate, I think I'm going to leave you guys at that. I'm going to share the files in the description as per usual, and in the future I will likely have improved head parts for this. I think one thing that would help would also be larger ports. If nothing else, it would increase pumping efficiency. Also, while developing this compressor, I am working on a high pressure water pump that kind of works on a similar system. I'm hoping to get that out before Christmas. Both of these contraptions being my Christmas contribution to the 3D printing community. And that's all I got for you guys today. If you liked it, you know what to do. Hit the buttons down below. I hope you guys have yourselves a good one. And I'm going to leave you with what looks like a ghost pushing over the compressor. I don't actually think it's a ghost, but anyways, have a good one, guys.